All right, if it makes you feel better, I got 2 wrong during this one. Okay, here we go. It says dy over dt is equal to that, and y of 0 is equal to 20. This is actually asking for, if this is the derivative, it's asking for the original. So in this situation, you're given a differential. They want you to find the initial, or the particular solution. That's what this is. This is a particular solution question. So you have dy is equal to negative 10 e to the negative t over 2 dt. And then you take the antiderivative, and the antiderivative 1 dy is just y. And then the antiderivative of that, does anybody know that antiderivative? It is 20. Very good. So if you use substitution, you would get a negative 1/2, multiply to come up with a negative 2. That would turn to 20. E to the negative t over 2, and then plus a constant. And so if the initial condition is 0, 20, let's plug in 0 for t. Negative 0 over 2 is 0. What is e to the 0? 1 times 20 is 20. So 20 is equal to 20 plus c. So the initial condition, c, is 0. So your function is y is equal to 20e to the negative t over 2. It says to find the value of y of 6. So we plug in 6, and you get negative 3 there. So we're going letter B. I am very frustrated about number 19. I got 19 wrong. I'll show you the mistake I made. It says let f be that function. At what value does f have, at what point does f have an inflection point? So inflection happens when? Second derivative changes sign. You have the first derivative, right? What's the second derivative? So when I did the second derivative, I did x squared minus 4. I forgot the 3, and so I chose 2 out of that. So I got that one wrong for that reason. As you solve for this, notice that this makes a graph. It crosses through negative 2 over the root of 3 and positive 2 over the root of 3. And so it changes sign right here. So 2 over the root of 3, that's your answer. Okay, so just to help you understand, a horizontal asymptote, that's what's happening as x goes to infinity and negative infinity. So really this question is saying, what is the limit as x goes to infinity of that function? That's all it's asking. And if you multiply that out, you get 2x squared, 8x, so negative 11x, which doesn't even matter, plus 12, over x squared minus 2x plus 1. So use Beta's idea from the other day. What's the limit of that function as x goes to infinity? 2, right? I mean, if you did our normal option, you would factor out an x squared. You get 2 minus 11 over x plus 12 over x squared. And at the bottom, you do x squared, and you do 1 minus 2 over x plus 1 over x squared. And you notice that those would just disappear. They'd all be gone. They'll be gone. You get 2. So the horizontal asymptote is the same thing as the limit as x goes to infinity, which is positive 2.
Okay, I have a question.
What?
So I didn't know what it was asking. So
yep.
It's something else. So I to get the same.
Good.
So no, like I don't think I did it right. I think maybe it was a coincidence. So like I saw 2 and I just plugged it in, and then I was like, oh, I got negative 2, and I was like, okay, 2 and negative 2, and then I fixed 2.
Morgan has invented a new branch of mathematics. It has no rhyme or reason to it. It makes zero logic, but it is a new branch, and you're more than welcome to sell a textbook. I might buy it.
All right, let's get a pattern.
Good job. Okay, I got this one wrong. I'm super mad at myself about it. Does anybody know what the square root of 1 minus x squared looks like? Okay, so this is an important element. I knew right away what it looked like. You don't have to necessarily know what it looks like. But if you notice, you're trying to find the area. I'll just draw what it looks like. the square root of that is simply a semicircle. If you had x squared plus y squared is equal to 1, notice what happens when you solve for y. You get y squared equal to 1 minus x squared. When you square root both sides, you get y is square root of 1 minus x squared. So it's simply just a semicircle. It's the top portion. So that's something that actually comes up every once in a while in the AP exam. Reviewing the equation of a semicircle is sometimes things that people want to know. When I set up the problem, I didn't do my bounds from -1 to 1. I just did 0 to 1, and I forgot to double it. So I got it wrong for that reason. So, but that's the way it is. Notice what the question says. It says that if you take a cross section, you get a square. And so you get this type of shape that's coming out at you. And we just have to be able to find that volume of that shape. Is the width dy or dx? It is a dx problem. And then I need this distance. What's the distance from the x-axis to the function? The square root of 1 minus x squared, which is also going to be that one, right? Which is the square root of 1 minus x squared as well. And so you come up with this equation, which is -1 to 1 of that times that, right? And what do you get if you multiply those two together? You get 1 minus x squared dx. Now, that's why I set up, but I had that at 0. Notice how the left and the right side are the same. So I'm going to go from 0 and I'm going to double it. But I was an idiot and do that. The antiderivative of 1 is x. The antiderivative of x squared is x cubed over 3. So I will determine that and double it. I plug in a 1 and I get 1. So 2 times 1 minus and then 1/3. And I get 1 minus 1/3 is 2/3. So I get 4/3 out of that deal. So let's just take a moment to step back. Have we practiced problems somewhat similar to that before? We have. The difference is that they've all been located in FRQs. Agreed? So notice the problem does become a little bit more challenging when they don't give you the graph, right? And trying to then, because when you saw that, you might be like, this doesn't look familiar to me. As you try to file it and pick, like, where does that come from, I get how that's difficult. As soon as I see this, solid, each cross-section perpendicular to x-axis, right away I say to myself, okay, that's like a part C from an FRQ. That's where I place that. And I did draw it correctly. I just went from 0 to 1. I read it too quickly. I just said we must just be working with the first quadrant, and that's where I made my mistake. Flip it over. Okay, not going to lie, we're getting some challenging problems here. So just lean in and focus the best you can. These are tough. This is a function defined by that where k is constant for what values, if any, is f strictly decreasing. Tell me about decreasing. What is negative? The slope is negative. So is f negative or is f prime negative? We're looking for where f prime is negative. So I want to take this derivative and find where f prime is negative. That's what I want to figure out. So let's take this derivative. What rule do I have to use? Quotient. Derivative of the top. Okay, times the bottom. Minus derivative of the bottom. Times the top. Kx. All over the bottom. Is everybody okay with what I have? So as I multiply through, I get kx squared plus k minus, what is that? 2kx squared. So it looks like I'm going to get k minus kx squared over x squared plus 1 quantity squared. Are we okay with that? I'm wondering where this is less than 0. So tell me something about the denominator. The denominator is always positive. So if I'm wondering where it's less than 0, I'm just wondering where the top is negative. Agreed? Okay, let's factor out the k, and we get k times 1 minus x squared. They're asking us on the interval of -1 to 1. Can somebody tell me what does 1 minus x squared look like on -1 to 1? That looks like a parabola like that, almost like a semicircle. Everybody agree that that thing looks like that? So this thing is always positive over that interval, isn't it? So what would make it negative if k was negative? Everybody see that? You have k times a positive over a positive. That's what we've deduced. So therefore, if k is less than 0, then it will be strictly decreasing. Letter A. We okay? I'm not going to lie. If you saw that one, would you just pass that one on by? Yep.
Circle and answer.
Okay, circle and come back. Maybe that's a tough one. Okay, I saw that one. I'm like, ooh, I love the question, but there's like 4 pieces that goes into that, right? Next one's challenging but very doable. It says write an equation for a line. Anytime I see that, I like that kind of question, right? What 2 things do we need? I need a slope and I need a point. So let's start with the point. What is the x value of the point? -1. Now, I'm going to plug in -1 into the function in order to come up with my point. What is an integral from -1 to -1? Integral means you're finding the area, right? So if you're finding the area from -1 to -1, what's the area? Nothing, right? Area from -1 to -1, there's going to be no area. As we expand, you're going to get area, right? So an integral from something to itself is just going to be 0. So you get 3 minus 0, which is 3. So you can see that the location is 3. I thought that all of these give you -1, 3, though, don't they? So that really didn't help us. So now we need the slope. Well, in order to find the slope, I need the derivative. So y prime, I'm going to take the derivative. Can somebody tell me the derivative of 3?
0.
Nothing, right? And then what happens when I take the derivative of an integral? The integral goes away. You do have that negative left, so -e to the -t cubed. And it's saying at -1. So if I plug in -1, -1 cubed is -1 times -1 is 1. So the slope is -e. Everybody see that? So therefore, this is my result.
I was always
Okay, I know that this isn't necessarily easy, but we have done this before, haven't we? Yeah, I'm gonna divide by y squared. I got dy over y squared is equal to 5dx. What's the antiderivative of 1 over y squared? Very good. -1 over y is equal to 5x plus c. Are you guys okay with me coming up with the initial condition right now? So I'm going to plug in 0 for x, and I get c is equal to -1/3. So I've got my constant. So -1 over y is equal to 5x minus 1/3. Now, when you get y in the denominator like this, maybe you recall that I like to take the reciprocal. So I would like to make one fraction here. So I'm going to do -1 over y is equal to 15x minus 1 all over 3. Now I'll multiply by a negative, and I get 1 over y is equal to 1 minus 15x over 3. And now I'll take the reciprocal, and I get y is equal to 3 over 1 minus 15x. And that's the correct answer.
I was confident in this too.
So very happy at how you guys are doing because even though you might be getting something wrong, many classes in the years past, they would have just, they would have quit a long time ago. So you guys are trying, which is a great thing to do. Okay. All right. Here's two questions that on a normal year, we would have been able to address a little bit more. This is a tough one. So this, you're going to get free points here. Okay. Shh. Everybody ready for free points? Okay. So when we first started out, we said this. We said, let's say that f of x is equal to x squared. I'll say x cubed, and you wanted to find f prime of x. Everybody remember us doing that? And what did you get for a derivative? 3x squared. But there was a time where you didn't know how to do that. And what you did is you did this crazy business. You said x plus h quantity cubed minus x cubed all over h, limit as h goes to 0. You guys remember doing that?
Yeah.
So here's the thing. This is the function. That's f. So when you look at this form, you can see what the function is. The function is sine. Okay? That's all it's asking you to do, to recognize that formula. The function is sine. What's the derivative of sine? Cosine. And then the point which we're evaluating is just pi over 3. So when you see this, you're just looking for the derivative of that at that point. That's all you're looking for. Okay? And you might see a question like that. Just focus. That's your function. It's asking for the derivative. Okay? Because if we work this out, you would come out with 3x squared. That's what this results to. So cosine of pi over 3. Anybody? Cosine of pi over 3? 1/2. Good. Okay. We missed question 26. I somehow deleted it, so give yourself a point for 26. Told you to get a free point.
Free point on what?
I deleted question 26 by accident, so just give yourself a point, okay? 27. This is one we were at the end of first semester. We didn't have time to cover it, so I didn't cover it. And here's the deal. If you have an inverse function and you want to take the derivative, there's a formula. Write this down. 1 over f prime of f inverse. 1 over f prime of f inverse. Super easy to get the points once you know the rule. Okay? Let me teach you just a little bit here. If I have the coordinate 3, 6, can somebody tell me what is f of 3 equal to? 6. That means that f inverse of 6 is equal to 3. So we see f inverse, that means if you're given a y coordinate, what's the x coordinate? So when it says in this situation that it wants to know the derivative of f inverse of 2, all we do is 1 over f prime of f inverse of 2. That's all we have to do. So if I see 2 and I see inverse, am I looking for 2 as an x value or am I looking for 2 as a y value? Y. So 2 is a y value here. What's the x value? 1. So now I have 1 over f prime of 1. What's the derivative of f at 1? Negative 8. So it's negative 1/8. Do you see how if you memorize that formula, that's really no big deal, is it? Yeah. So f of 3 means if 3 is an x value, we get a y value. If you see f inverse, it means that's a y value. What is the x value? That's what the meaning of function inverse is. Okay, this is the last question on the non-calculator portion of the multiple choice. This one's a doozy. Anybody see that's a related rates problem? Let's talk about it. So the top of a 15-foot ladder. Does the length of the ladder change? No, it doesn't. So I'm going to call it 15. Okay. Does the height of the ladder change? Yes, I'll call that H. Does the base of the ladder change? Yes, I'll call that B. Okay? So it says the ladder is sliding down at a constant rate of 2 feet per second. That means that H prime is equal to 2, so that piece I know. And it says at what rate in radians per second is the acute angle between the bottom of the ladder and the ground changing at that time. When the ladder is 9 feet from the base of the wall. So we're going to say that the base is equal to 9 at that time. Can somebody come up with, so we're trying to solve for B prime, aren't we? Is that what we're trying to find? Okay. So, yes. You could call it -2. We'll sort that out in the end. Doesn't really make a huge difference. So, but yes. Okay, so can somebody come up with a trig function that has to do with an angle, and then this side, and then this side? Good. So sine of theta is equal to what over what? H over 15. Now, this is a related rates problem because it's all changing with respect to time. Right? So I'm going to take the derivative with respect to time. This is where it gets a little tricky. What is the derivative of sine? Cosine. And remember, when you take the derivative using implicit differentiation, you have to attach a y prime all the time, don't you? Or in this case, you have to attach a theta prime. Pause for a second as I write this. Area is equal to pi r squared. When you took the derivative with respect to time there, you had a prime was equal to 2 pi r r prime. Did you not attach an r prime in that situation? So notice in this situation, the angle is theta. So I attach a theta prime. What is the derivative of h over 15? 1 over 15 times h prime. Very good. You're almost there. What is h prime in this problem? -2. So I get -2 over 15. That's what you get on that side. On this side, it's asking me for what rate is the angle changing. So I'm trying to solve for theta prime. We need cosine of theta. Cosine is what over what? Adjacent over hypotenuse. What is the adjacent over the hypotenuse at this time? 9 over 15. So 9 over 15 times theta prime is equal to that. So I would solve by simply multiplying both sides by 15 over 9. And notice you get -2/9. Folks, those are not the kind of questions I'm going to be asking you to perform before you take our that's a tough problem. I love it. It's super cool, but that's tough. Shh. Okay, let's try something we know how to do. Okay, it says let R be the region in the first quadrant enclosed by these two graphs. Which one's on top? Square root of x or x over 3? Root of x is on top, so we have g of x is equal to the square root of x. And on the bottom we have h of x is equal to x over 3. So what's nice is that when you're doing the multiple choice, at least you can guess something. But what's nice about the free response is you know what you at least get partial credit, right? So, and hopefully you found this problem fairly gettable. Find the area of that region. Well, how am I going to find the area of region R? Integral of top minus bottom. So good. So we have square root of x minus x over 3 dx. And you're going to integrate from where to where? 0, 9. Good. Let's just evaluate that. You put a pi in there? There's no circle. So that's really when you get to have volume and you have
I
rotations.
just thought that pie made me sound sophisticated.
Thank you for your honesty. You were wrong. Okay, antiderivative of the square root of x. 2/3 x to the 3/2 power. And then antiderivative of x over 3 should be x squared over 6. And we're going to evaluate at 9 and 0. So I plug in 9. Square root of 9 is 3 cubed. 27. Divided by 3 is 9. Times 2 is 18. And then I get 9 squared is 81 over 6. Or 27 over 2. And so I get 36 over 2 minus 27 over 2 is 9 over 2.
So I didn't get that? Okay, good. But I was right in my calculation.
Show of hands if you got 9 over 2. Hey, way to go. Nice job. Nice job.
Well, I get no points back by the pie, even though I didn't know it, right?
Well, little drama, Morgan. Little drama. So we're going to take this and we're going to rotate it above y is equal to 4. So what shape are you going to get if you rotate this above y equals 4? You're going to get a washer, yeah. You can see that that's the inside of your washer and then that's the outside of your washer. So I'm going to use my method because I really do like my method. I'm going to redraw it here so I don't make a mistake. And as I redraw it, I'm going to put these dotted lines in.
Yep, I did it wrong.
Okay, what makes up the center? Y equals 4. What makes up the outside? H of x. And what makes up the inside? G of x. And so I also have a width of dx. So when we do pi times big R squared minus little r squared, pi times big R squared. What is big R? 4 minus h of x, that quantity squared, minus 4 minus g of x, that quantity squared dx.
I always do the g of x minus h of x. How do you know if it's closer or not? It looks pretty close on my paper.
Sorry, Morgan.
How do you know which ones are closer, though?
Question.
The middle?
Yes, so if you wrote x over 3 there, that's fine. Yep, very good. Oh, I'm sorry. So I wouldn't get these points. I'd have to bound it 0 to 9. Thank you. Yep, got to put my bounds on. Okay, last one. Good job. You guys have done a great job. This is a beautiful problem. I love the way that this is set up. You could totally have success with this. It says find the maximum vertical distance between the graph of G and the graph of H between 0 and 16. So please look at the original problem right here between 0 and 16. So 16 is going to be somewhere out there. How do we find the distance between two graphs? Top minus bottom, right? So let's write this out. Distance between the two graphs is equal to the top minus the bottom. So top is going to be g of x, right? Minus f of x. Okay? And then it switches, doesn't it? Okay? So we could consider that later, but our distance is equal to that. It's asking us to find the maximum. How do we maximize something? We take the derivative and set it equal to 0. So I take the derivative, say equals 0. What's the derivative of g? G prime minus f prime. So let's find the derivative of g. Somebody, what is the derivative of g? G is the square root of x, right? What's the derivative? 1 over 2 roots of x. And what is the derivative of f? 1/3. So I just want to solve that. So I'm going to add the 1/3 over to the other side. I get 1/3 is equal to 1 over 2 roots of x. And I cross multiply. I get 2 roots of x is equal to 3. Somebody, how do I solve for x? Yeah, so I get square root of x is equal to 3/2. So x is 9/4. So is 9/4 somewhere between 0 and 16? Yeah, it sure is. That's my x value. If you want to consider maximum, again, you must consider the following things. You must consider the beginning, the chain, and then the end, and then the spot in the middle. So we're going to consider the beginning where it's at 0, the end where it's at 16, and then the middle value of 9/4. It asks us to actually find the distance. You guys told me the distance to the top minus the bottom, right? So square root of x minus x over 3. If x is 0, what's the distance between the two of them? 0. If x is 9/4, what's the distance between them? What is the square root of 9/4? 3/2 minus 9/4 over 3, or 9/12. So 3/2 minus 9/12, that would be 18/12 minus 9/12 is 9/12, otherwise known as 3/4. That's that distance. And then if you check 16, remember out there it's this one minus that one. So it's 16 over 3 minus the square root of 16. And in that case, I get 5 1/3 minus 4, which is 4/3. So you could tell that the maximum distance is 4/3. That is my justification. Let's check out the AP result to see exactly what we have. Here it is.
I won. I knew it was around 1. Yeah, was the last problem count? Like on the back.
Oh, so the last one, we won't have time to do, but I forgot I had assigned you 2. So we'll go over that tomorrow while people are gone.
I'm not here. Is it this?
So that's number 6. That's a whole nother problem. That's a second free response.
Yeah.
Okay. Shh. So here you are. You get 1 point if you have the integral of g of x minus f of x dx, 0 to 9. So if you have the integral, that gives you 1 point. If you came up with the correct antiderivative, which is 2/3 x to the 3/2 minus 1/6 x squared, then you get a point for that as well. And finally, you do get 1 point if you have the 9/2 correct.
So do I not even get 1? I'm giving myself.
Okay, for part B, if you had the limits from 0 to 9 and pi, you get 1 point for that limit. If you had 4 minus f of x, or h of x, and then 4 minus g of x, those quantities squared, you get 2 points for that proper integral.
I feel like you did one of them wrong.
What do you mean, one of them?
Like, I did 4 minus h of x squared, but then I got the second one wrong.
Then you would not get those 2 points. And then part C, I did set those functions equal to 0, and I actually said distance is equal to something. It looks like that's what they want. And so I did get that correct. Consider where it's equal to 0. We found 9/4 to be a candidate, didn't we? So you get a point if you find the 9/4. Your answer is 4/3, but you also have to have the justification. Notice how much work it took us to come up with that 4/3 and the justification. That's just 1 point. So you can get a lot of points even without doing that part. So please keep that in mind. Question? So how about we do the second pre-response? We'll go over that tomorrow, okay?
What is the sound
Then you can just check out the video.
Oh.
But for people who are here tomorrow, you can work on number 4 in class. How's that? If you're not here tomorrow, then just work on number 4 over the weekend. Is that fair enough? We okay with that? So you may use your calculator for this one. This is number 4. You just have one left. You guys are doing a great job. Way to go.